Hello everyone, welcome back to another video from my channel. In our last video, we discussed about the differentiation of trigonometric functions or sinusoidal functions like sin x, cos x, tan x, and etc. Today, however, we will be looking at the differentiation of exponential and logarithmic functions. But before we go right into it though, let us review some of the laws and rules of indices and logarithms. For the first rules of indices, we have a to the power m multiplied with a to the power n is equals to a to the power m plus n. For the second one, we have a to the power m divided by a to the power n, which is equivalent to a to the power m minus n. So giving an example for the first and second one, we have 2 cubed multiplied with 2 squared, and according to the indices rules, we should have 2 to the power 3 plus 2, which is 2 to the power 5 or 32. On the left hand side, we have 2 cubed, which is 8 multiplied with 4, and 4 into 8 is 32. And for the second one, we have 2 cubed divided by 2 squared, and we are supposed to get 2 to the power 3 minus 2, which is 2 to the power 1 or 2. And if you see 8 divided by 4, we should have 2 itself. For the third rule, we have a to the power m multiplied with b to the power m is equals to a into b whole to the power m. And for the fourth rule, we have a to the power m divided by b to the power m. So we will have a divided by b whole to the power m. For number 5, anything to the power 0 will always be 1 except for 0. For number 6, we have a to the power m whole to the power n is equals to a to the power m multiplied with n. For example, if we have 2 squared whole cubed, we should have 2 to the power 2 into 3, which is 2 to the power 6, or simply 64. And on the left hand side, we have 4 cubed, which is 4 into 4 into 4, as 4 into 4 is 16, and multiplied with 4 gives us 64. For the seventh rule, we have a to the power minus m is equals to 1 by a to the power m. For number 8, we have a to the power m by n is equals to nth root of a to the power m. And similarly for the logarithms, if we have x equals to a to the power m, then log base ax is equals to m, where a is a base number and m is our power. So for the first rule, we have log base a m multiplied with n is equivalent to log base a m plus log base a n. For the second rule, we have log base a n divided by n is equals to log base a m subtracted with log base a n, similar to the first and second rule of indices. An example for the first and second rule would be, let's say if we had log base 2, 3 plus log base 2, 6, then we can multiply them according to the rule to get log base 2, 3 into 6, which is log base 2, 18. And similarly for the second rule, we have log base 2, 3 subtracted with log base 2, 6 will be log base 2, 3 divided by 6, which is half. So we can write that being log base 2 half. For the third rule, we have log base a m to the power m. So we can also rewrite that being n multiplied with log base a m. For the fourth rule, we have log base a of a will be 1. And similarly, log base a1 will be 0. Because if we had log base a1, 1 can be written as a to the power 0, as according to the fifth rule of the indices. Therefore, we can also write that being log base a to the power 0, and so we can write that being 0. For the sixth rule, we have log base a x to the power m into n, which can be written as m into n multiplied with log base ax, similar to the third rule. And finally, we have log base a 1 by m to the power n, which is equivalent to minus n log base am. So according to that rule, we can also write log base 2 half is equals to log base 2 to the power minus 1. And as log base AA is equals to 1, so we can write that being minus 1. So let's imagine you have deposited $1 to a bank account that has a very generous interest rate of 100% per year. So after 1 year, the value of your account will be 1 plus 1 by 1 whole to the power 1 is equals to 2, as shown in the table. And if the interest was calculated every half a year, which is semi-annually, then you would get 1 plus half whole to the power 2 or squared is equals to 2.25. And if it was for 1/4 of the year or quarterly, then you would get 2.441406. And for monthly, you would get 2.61303529. And for weekly, you would get 2.69259695. And if it was calculated daily, then the value of the account will be 2.71456748. And if it was calculated hourly, then you would have 2.71812669. And if it was calculated every minute, then the value of your account will be 2.71821154. And for every second, you would have 2.71828247. As you can see, if the time scale decreases, and becomes shorter and shorter, then the value of your account will be closer to a constant value, which is also known as E, or natural number, because it arises naturally in mathematics and has real life implications. It is also known as Euler's number, and mathematical notation of it will be limit of t tends to infinity 1 plus 1 by t whole to the power t is equals to E, or limit of t tends to 0 1 plus t whole to the power 1 by t is equals to E. So now let's move on to differentiation of log base ax from first principles. So if you remember from my previous videos, dy by dx is equals to limit of h tends to 0 function of x plus h minus function of x whole divided by h, which is also known as the gradient function, or delta y divided by delta x, rise over run. So applying the formula, we have dy by dx is equals to limit of h tends to 0 log base a x plus h subtracted with log base ax whole divided by h. And using the logarithm rule, log base a m by n, we have log base am subtracted with log base an. So we can also combine this expression together to form limit of h tends to 0 1 by h log base x plus h divided by x. So dividing the expression with x, we get log base a 1 plus h by x. Now we will say that let h by x is equals to t. So our expression becomes limit of t tends to 0, as we don't have h anymore. So we have 1 by tx multiplied with log base a 1 plus t, and according to the logarithm rule of log base a, x to the power m is equals to m multiplied with log base ax. Then we can also write this being limit of t tends to 0 1 by x multiplied with log base a 1 plus t whole to the power 1 by t. And according to the limit that I discussed before, which is limit of t tends to 0 1 plus t whole to the power 1 by t is simply equals to e, or the natural number. So simplifying and applying the limits, we have 1 by x log base a e, or we can write that being 1 by x ln a, where ln is the logarithm of base e. So now we have found out the derivative of log base ax, which is 1 by x log base ae, and when the base a becomes e, then we have ddx of ln x is equals to 1 by x, as log base ee is simply 1, which is one of the rules of logarithms. So we have the formulas of ddx of e to the power x is simply e to the power x, where e is the Euler's number or natural number. ddx of a to the power x is simply a to the power x multiplied with log base ea, or simply a to the power x multiplied with ln a. Similarly, for ddx of ln x, we have 1 by x, and for log base ax, we have 1 by x multiplied with log base ae. So now let's look at a very important concept from coordinate geometry, which is finding out the equations of tangents and the normals of any curve function of x. So for the first rule, we have the equation of a straight line that passes through the points x1, y1 and x2, y2 is y minus y1 is equals to y2 minus y1 divided by x2 minus x1 multiplied with x minus x1, or it can be also written as y minus y2 is equals to y2 minus y1 divided by x2 minus x1 multiplied with x minus x2. Visually speaking, if we have a straight line that passes through the point x1, y1 and x2, y2, then the equation of this straight line L will be y minus y1 is equals to y2 minus y1 divided by x2 minus x1, or it also can be written as y1 minus y2 divided by x1 minus x2, and then multiplied with x minus x1. So if you notice that this expression is actually the expression for the gradient, where the gradient m is equals to delta y divided by delta x. So in the second form, we have the equation of a straight line that passes through the point x1, y1 and has a gradient of m is equals to y minus y1 is equals to m multiplied with x minus x1. Simply y minus y1 is equals to m multiplied with x minus x1, which is an alternative form of the first equation. And we have the very important relationship between two perpendicular lines L1 and L2. What it means is that if we have the straight line L1 and another straight line L2, the angle between them will be 90 degrees, meaning that they are perpendicular. And if L1 has gradient m1 and L2 with m2, then we have m1 multiplied with m2 is equals to minus 1, or simply written as m1 is equals to minus 1 by m2. So now let's move on to some exercises. For number 1, we have to differentiate the expressions with respect to x. So for number A, we have ddx of e to the power 4x divided by cos x, simply be v multiplied with du by dx, which is the derivative of u minus u multiplied with dv by dx and whole divided by v squared. So applying the same formula, we have cos x whole square at the bottom. At the top we have cos x multiplied with v dx of e to the power 4x subtracted with e to the power 4x and then multiplied derivative of cos x. So simplifying, we have cos squared x at the bottom again. At the top of the numerator we have cos x multiplied with the derivative of e to the power 4x. Now if you remember, the derivative of e to the power x is simply e to the power x. So we can write that being e to the power 4x. Because we assume that the 4x is a single function, therefore we have to multiply it with the derivative of the inner function, which is 4x again. According to the chain rule, we subtracted by e to the power 4x multiplied with the derivative of cos x, and if you remember my previous video, ddx of cos x is minus sin x. So simplifying, we have the derivative of 4x is 4, so we have 4 e to the power 4x and multiplied with cos x, and then we have minus 1 multiplied with minus 1, which is 1. So we have e to the power 4x multiplied with sin x, and then whole divided by cos squared x. So we can also take a common factor of e to the power 4x to get e to the power 4x divided by cos squared x, and we have brackets of 4 cos x plus sin x, and this is our answer. For number B, we have ddx of e to the power minus 2x plus e to the power 2x whole divided by ln x. So again, using the quotient rule, we will have ln x whole square at the bottom, and then ln x, and then ln x multiplied with the derivative of e to the power minus 2x plus e to the power 2x and subtracted by e to the power minus 2x plus e to the power 2x multiplied with the derivative of ln x. So simplifying, we have ln x, and ddx of e to the power minus 2x is minus 2 e to the power minus 2x using the chain rule like before, and for e to the power 2x we have 2 multiplied with e to the power 2x and then subtracted again by e to the power minus 2x plus e to the power 2x multiplied with the derivative of ln x, which is 1 by x as discussed before, and whole divided by ln x whole squared. So multiplying the terms, we have minus 2 ln x multiplied with e to the power minus 2x plus 2 ln x e to the power 2x, and then minus 1 by x of e to the power minus 2x minus 1 by x multiplied with e to the power 2x, and then whole divided by ln x whole squared. Taking a common factor of minus e to the power minus 2x, we have 2 ln x plus 1 by x, and taking a common factor of e to the power 2x, we have 2 ln x minus 1 by x, and then whole divided by ln x whole squared, and this is our answer. So for number C, we have to find the derivative of sine squared x divided by ln x. So using the quotient rule again, we have ln x squared at the bottom or the denominator. At the numerator we have ln x multiplied with the derivative of sine squared x subtracted with sine squared x multiplied with the derivative of ln x. So simplifying, we have ln x squared at the bottom again, and at the numerator we have ln x multiplied with the derivative of sine squared x, and using the chain rule we assume that this is a single function. So using the power rule first, we have 2 sine x and then multiplied with the derivative of sine x, and if you remember the power rule, we had if y is equals to ax to the power n, then dy by dx will be equals to an x to the power n minus 1, which is discussed in my first video. So subtract it with sine squared x and then multiply it with the derivative of ln x, which is 1 by x. So ddx of sine x is cos x from the previous video. So we will have 2 sine x cos x ln x subtracted with 1 by x of sine squared x, and whole divided by ln x whole squared. So we can also write 2 sine x cos x as being sine 2x, as if you remember the formula sine a plus b from my previous video, which is sine a cos b plus cos a sine b. So substituting a equals to b yields the equation sine 2a is equals to 2 sine a cos a. So writing that down, we have sine 2x multiplied with ln x subtracted with 1 by x sine squared and then whole divided by ln x whole squared. For number d, we have ddx of ln x divided by x plus 1. Applying the quotient rule, we have x plus 1 whole square at the bottom. At the top we have x plus 1 multiplied with the ddx of ln x subtracted with ln x multiplied with the derivative of x plus 1. So differentiating the expression, we have x plus 1 multiplied with 1 by x, as the derivative of ln x is 1 by x, and then ln x multiplied with 1, as the derivative of x is simply 1 and the derivative of any constant, which is 1 here, is 0, and then whole divided by x plus 1 whole squared, and then further simplifying, we have 1 plus 1 by x minus ln x and then whole divided by x plus 1 whole square. And this is our answer. So for number 2, we have to find out the equation of the tangent of curve y is equals to e to the power 1/3 x divided by x at point 3 1/3 e, where e is the natural number or Euler's number if you remember. So first we have to find out dy by dx, which is ddx of e to the power 1/3 x divided by x. Using the quotient rule, we have x squared the denominator, and the top we have x multiplied with the derivative of e to the power 1/3 x e to the power 1/3 x subtracted with e to the power 1/3 x multiplied with the derivative of x. So simplifying, we have x multiplied with 1/3 e to the power 1/3 x using the chain rule, subtracted with e to the power 1/3 x into 1 as the derivative of x is 1 using the power rule, and then whole divided by x squared. So we have to find the dy by dx, or the gradient, at x equals to 3, so that we can use the formula y minus y1 is equals to m, or gradient, multiplied with x minus x1. So when x is equals to 3, dy by dx is equals to 3 into 1/3 e to the power 1/3 multiplied with 3 subtracted with e to the power 1/3 into 3 again, and divide by 3 squared. So at the top we have 3 into 1 by 3, which is 1, and similarly 1 by 3 into 3 is also 1. So we have 1 e to the power 1 subtracted with 1/3 into 1, 1/3 into 3 is also 1, so we have minus e divided by 9, and e minus e is 0, so we have the gradient being 0. So therefore the equation will be y minus y1, which is 1/3 e, is equals to gradient, which is 0, into x minus 3 according to formula. So we have y is equals to 1/3 of e. Graphically speaking, what it basically means is that the tangent is a horizontal straight line at 1/3 e. For example, if the graph was like this, then the tangent will be exactly at this point. We have function of x is equals to x cubed subtracted with 2x whole multiplied with e to the power minus x. So we have to find out f dash x, or the derivative of function of x. So applying d dx of x cubed minus 2x multiplied with e to the power minus x. We have to use the product rule, right? If you remember, if we had y is equals to uv, then dy by dx will be equals to u multiplied with dv by dx, or the derivative of v, and then plus v multiplied with du by dx. So applying the formula, we have x cubed minus 2x, x cubed minus 2x multiplied with the derivative of e to the power minus x plus e to the power minus x multiplied with x cubed minus 2x. So we have x cubed minus 2x with the derivative multiplied with the derivative of e to the power minus x, which will be minus e to the power minus x, using a chain rule, plus e to the power minus x multiplied with 2 squared multiplied with 3x squared subtracted with 2, and taking e to the power minus x as common factor, we have minus x cubed plus 3x squared, then plus 2x subtracted with 2. So for number B, they said that the normal to C at the origin O intersects C again at P. So we have to find out the equation of the normal at the origin, which is O at 0, 0. And so first we have to find out the value of dy by dx at x is equals to 0. So we can also write that in that way, and we will get e to the power minus 0 multiplied with minus 0 cubed plus 3 into 0 squared plus 2 into 0 minus 2. Anything to the power 0 is equals to 1 except for 0. So we will have 1 here multiplied with 0, 0, 0 minus 2. So we should have minus 2 here. So the gradient of the tangent at the origin is minus 2. So if you remember the relationship between the two perpendicular L1 and L2, then if they have the gradients m1 and m2 respectively, you have the relationship m1 is equals to minus 1, and we have the relationship m1 is equals to minus 1 by m2. So a normal in mathematics means that if we have the surface, then the perpendicular is called the normal. So therefore we can say that the gradient of the normal will be minus 1 by minus 2, which is half. And so we can find the equation of the normal as being y minus y1, which is 0, multiplied with the gradient, which is half, multiplied with x minus 0, which is x1. And so we have the equation of the normal to the origin at y is equals to half x. So because the normal meets the curve again, we have to equate both of the functions. So we can write that being x cubed minus 2x multiplied with e to the power minus x is equals to half x. So we can take a common factor of x here, and we'll get x multiplied with e to the power minus x multiplied with x squared minus 2 is equals to half x. So moving these terms to the right, we have x squared minus 2 is equals to half e to the power x. So finally, we can multiply both sides with 2 to get 2 squared, to get 2x squared minus 4, to get 2x squared minus 4 is equals to e to the power x. And so we can rearrange, write this being e to the power x plus 4 is equals to 2x squared. And if you notice, this is our required answer. For number 4, we have y is equals to e to the power 2x minus ln x, and so we have to find out the equation of the tangent at point x equals to 1. So doing a little bit of planning, you can see that our equation will be found out using the formula y minus y1 is equals to m into x minus x1. So we need y1 as well as m. So first, we will say when x equals to 1, y is equals to e to the power 2 into 1, which is 2, minus ln 1, which is 0, as logarithm of 1 is always 0. So we will have e squared as the y coordinate. And now we can find out the derivative of y, which is dy by dx, or the gradient function, which will be ddx of e to the power 2x minus ln x. So we will have e to the power 2x multiplied with 2 using the chain rule. So we have 2 e to the power x. So we have 2 multiplied with e to the power 2x subtracted with 1 by x, as derivative of ln x is 1 by x. So when x equals to 1, dy by dx being equals to 2 into e to the power 2 into 1. So we have e squared. So we have 2e squared minus 1, as 1 by 1 is 1. So now, applying the formula of the equation of the tangent, we have y minus y1, which is e squared, is equals to the gradient, which is 2e squared minus 1, multiplied with x minus x1, which is 1. So rearranging, we have y is equals to 2e squared minus 1 multiplied with x minus 2e squared plus 1 multiplying 2e squared minus 1 with x, as well as 2e squared minus 1 with minus 1, and then Adding both sides with e squared, we have plus e squared. And so simplifying, we get 2e squared minus 1 multiplied with x minus e squared plus 1, and this is our required answer. For number 5, we have y is equals to x squared cos x squared. So we can find that dy by dx is equals to ddx of x squared cos x squared, and so we can get x squared multiplied with ddx of cos x squared plus cos x squared multiplied with the derivative of x squared. So we have x squared multiplied with the derivative of cos x squared, which will be minus sine x squared, because we assume that this was a single function, and the derivative of cos x is minus sine x, and then using the chain rule, we have to multiply it with the inner function, which is x squared, so ddx of x squared, and then plus, here we have cos x squared multiplied with 2x, as the derivative of x squared is 2x. So here we have 2x here as well. So finally, we can write that being 2x cubed, as x squared multiplied with x is x cubed, multiplied with sine x squared plus 2x cos x squared. So now at point P, where x is equals to root pi by 2, then dy by dx is equals to minus 2 into root pi by 2 whole cube and then multiplied with sine root pi by 2 whole squared plus 2 multiplied with root pi by 2 and then cos root pi by 2 whole squared. So we have minus 2 multiplied with pi root pi, as root pi cube is basically root pi squared into pi. So we can write that being pi root pi and then divided by 8, as 2 cubes is 8, and then multiplied with sine pi by 4 and then plus root pi, as 2 into half is 1, So multiply it with cos pi by 4 and simplifying we have minus pi root pi divided by 4 multiplied with sine pi by 4, which is also sine 45 degrees, or root 2 by 2 plus pi into root 2 by 2 again. We can take a common factor of root 2 pi to get half minus pi by 8, which can be simplified to be written as 4 minus pi whole divided by 8, and this is our gradient at P. The coordinates are root pi by 2 and pi root 2 by 8. Using the formula y minus y1, we have y minus pi root 2 by 8 is equals to the gradient, which is root 2 pi multiplied with 4 minus pi by 8 into x minus x1, which is root pi by 2. So multiplying both sides with 8, we have 8y minus pi root 2 is equals to root 2 pi multiplied with 4 minus pi multiplied with x minus root pi by 2, 8y minus root pi by 2. So we multiply this to get root 2 pi or minus pi x, and then minus we have root 2 pi multiplied with root pi by 2 to get pi root 2 by 2, as root pi into root pi is equals to pi to the power 1. So we have pi root 2 by 2 multiplied with 4 minus pi, and then bringing all of the terms to the left side, we have root 2 pi minus 4, as we can take a common factor of minus 1 to get pi minus 4, and then plus 8y minus pi root 2 plus pi root 2 by 2 multiplied with 4 minus 5 is equal to 0. So we have root 2 pi multiplied with pi minus 4x plus 8y, and taking a common factor of pi root 2, and taking a common factor of minus pi root 2, we should have the fraction pi minus 2 by 2 is equal to 0. And this is our final answer in the form of ax plus by plus c is equal to 0. So thank you guys for watching. Please give a like, share, comment and subscribe, and see you guys in the next video.